Good morning, all. I hope all are doing well. And we are at the very crucial period for our gate preparation. And I would suggest you to practice as many number of questions as possible in this 1.5 month period. Most probably the previous year gate questions, because it is very common practice that most of the gate questions will be repeated from the previous year gate questions. So once you are aware of the previous year questions and their concepts, then you would be able to solve minimum 50 to 60 marks questions in a gate exam. So without wasting your time, let's get started. So today we are going to solve engineering mechanics previous year questions. So let's take the question number 1. So here it is stating that a spring scale indicates a tension T in the right hand cable of a pulley system as shown in the figure. Neglect the mass of the pulleys and ignoring the friction between the cable and the pulley, the mass M is. So that is the question. So here what is he saying is the friction between cable and the pulley is frictionless. That means there is no friction between pulley and the cable. Suppose let's take the free body diagram of this particular pulley. I could say A. So once we cut here, so we will get the tension in the spring. So if the friction is 0 between the pulley and the string, then the tension in the right and left side is same. Suppose if there is a friction here, if you are trying to pull this down, then the friction will act this side, so it will become T1 T2. If you try to pull this side, then friction will act this direction, so that way the tension in both the strings will be different. Now the condition here is the friction between the pulley and the cable is 0. That means it is a frictionless. So whatever the tension which is in the left side, you will get on the right side. So let's take the free body diagram of this mass M. So there is a weight mg and there is a tension T and there is a tension 2T in the cable, and here as it is a spring, whatever the weight whatever the tension which is there, the same tension is going to reflect on the spring. So that is the tension T. So now the body is in equilibrium condition. So we will use the equilibrium equation, that is summation of forces in the y direction or vertical direction are 0. So T plus 2T plus T is equal to mg, 4T is equal to mg. So mass is equal to 4T by g. So the option is C. Now let's move on to the question number 2. So question number 2 is related to the virtual work. I hope you all know what is the virtual work. So I'll recall it for you. Let's take a body A and which is acted by a force P. Now let's consider the virtual displacement of delta x in the direction of P. Virtual means this is not the actual displacement. We are assuming that due to force P, the body is elongated by delta x in the direction of P. So what is the virtual work states? The virtual work is nothing but the work done by the force along the displacement. That is the virtual work. That is the work by the actual force and the virtual displacement. This is the virtual work. This virtual work principle is mainly used to solve some of the engineering mechanics problems. So then let's come to the question. If a system is in equilibrium, that means a system is there and it is in equilibrium due to different forces, moments, whatever it might be, and the position of the system depends upon many independent variables. The principle of virtual work states that the partial derivatives of its total potential energy with respect to each of the independent variable must be. So here, let's take a body. The position P is a function of x, y, z and n number of independent variables. So what is the potential energy? Potential energy is nothing but the energy which is associated with position. That is potential energy. That means potential energy here is a function of position. Position is a function of number of independent variables. What is the virtual work states that the partial derivative of potential energy with respect to independent variable is 0. This is the statement of principle of virtual work. So according to this, the answer is B. Let's move on to the third question. Question number 3. If a point A is in equilibrium under the action of applied forces, the value of tension TAB, TAC are respectively. So here the body A is in equilibrium under 3 forces. So before solving the question, I want to tell you the 3 points regarding the equilibrium of a body. Suppose if this body is under equilibrium due to 3 forces, then the 3 forces must be concurrent in nature. That means their line of action should meet at one point. Then only this body can be under equilibrium. If any of this forces line of action is not meeting at this point, then this body cannot be under equilibrium. If anybody, let's come to the case number 2. If any body is under equilibrium due to 2 forces, then those 2 forces should be collinear in nature. That means their line of action should pass through each other. Then third point. This is called principle of transmissibility. That means suppose if this is the force F which is acting on a body A, so I can represent this force along the direction at any point. That means I can move this force vector along any point along the line of action, along the direction. That is called principle of transmissibility. So now here the body is under equilibrium due to 3 forces and those 3 are concurrent in nature. So to solve this problem, we have a Lami's theorem. There is one Lami's theorem. What Lami's theorem says is, if the body is under equilibrium due to 3 forces, then force divided by sine of angle between the 2 other forces. So what is the angle between these two forces, TAB and TAC? The total angle is 180. So 180 minus 60 plus 30, 90. So 180 minus 90 is equal to the force TAC divided by the angle between the 2 other forces. What is the angle here? Sine of 90 plus 60 is equal to the other force TAB divided by the angle between the 2 other forces, that is sine of 90 plus 30. So this is the principle of Lami's theorem, that is the force F and the sine of angle between the 2 other forces, the force TAC divided by sine of angle between the 2 other forces. So this is a variation of sine's rule that we will discuss later. So let's solve this problem. So what is TAC? TAC is equal to 600 divided by, what is sine 180 minus 90? Sine 90 into, if this comes here, what is sine 90 plus 60? That is cos 60. So 600 into cos 60 is equal to 1 by 2. sine 90 equal to 1. So the answer is 300 Newton. So what is the value of TAC? TAC should be 300 Newton. That means the answer is A. You don't have to solve TAB because there is no, the TAC is 300 only for option A. So let's move on to the question number. So here I want to give you one more rule, that is sine rule. This sine rule is applicable for any vectors, whether it is force or velocity, acceleration, displacement. For any vectors we can use this sine rule. That means consider a triangle ABC. So the angle opposite to the A is theta A, the angle opposite to the B is theta B. So you consider this as a theta C for time being. Okay, so what it says, suppose I will consider this as a P, Q, R. P by sine theta C means P by opposite angle is theta C, sine theta C is equal to Q. Q by opposite angle is theta B. So sine theta B equal to R. R by opposite angle sine theta A. So the opposite angle of R is theta A. That's why we are using here theta A. So here P can be force or velocity or acceleration or displacement. So this thing we can use it for any vectors. So let's go to the problem number 4. So here he is saying that two steel truss members AC, BC, each having cross-sectional area of 100 mm square, cross-sectional area 100 mm square, are subjected to horizontal force F as shown in the figure. All the joints are hinged joints. That means there will be only forces as the reactions. There is no momentum as a reaction. If F is equal to 1 kilonewton, the magnitude of the vertical reaction force developed at point B. That's what he is asking. That means what he is asking is, if you remove this hinge joint, then hinge joint will have FBX, two reaction forces. So FBX, FBY, because it is a hinge joint, it is only having two force reactions, FBX, FBY. It doesn't have a momentum because at hinge momentum is not restricted. So for time being I consider this FBX, FBY directions like this. While solving the question, if you get the force values as a negative, that means whatever the sign that we have taken is wrong. That means you have to change the direction of the force which we have taken. So let's cut here. It will be FBC. So here with respect to horizontal, the angle between this BC member is 60. So here also it will be 60. So what he is asking? He is asking FBY. So as the system is in the equilibrium, so we can use sum of Fy is equal to 0 equation. If you use this equation, so what we will get? FBC sine 60. That means this FBC force we can resolve into two components. FBC cos theta will become horizontal force. FBC sine 60 will become vertical force. So FBC sine 60 is equal to FBY. If you know FBC, then we can easily solve FBY. So how do you know, how can we calculate FBC? So from this free body diagram, that means free body diagram of joint C. Joint C is having external force F, and if we cut here, then we can take the reaction force FAC. If we cut here, we can take the reaction force FBC here. So here the joint is under equilibrium due to three forces, and these three are concurrent, and they should be concurrent because it is under equilibrium. So we can use the Lami's theorem, and by using Lami's theorem we can solve this problem. Okay, let's use Lami's theorem. FBC by the angle between two other opposite forces is nothing but, what is this angle? This angle is, total is 180, 180 minus 45, sine of 180 minus 45 is equal to FAC, FAC by the angle between opposite forces. That means total is 180, 180 minus 60 is this angle, 180 minus 60 is this angle. This is 180 minus 60, this is 180 minus 45. This is sine of 180 minus 60 is equal to force by, what is the angle between these two? Sine of 60 plus 45 degree. So we need only FBC and we know the value F. So we will relate these two equations. So FBC by sine 180 minus theta. Sine 180 minus theta is nothing but sine theta. So sine 45. F we already know, 1 kilonewton divided by sine 60 plus 45, sine 105. FBC is equal to 1 kilonewton into sine 45 divided by sine 105. So if you solve it, you will get 0.63 kilonewton. So our option is option A. Let's start question number 5. So what is question number 5? A ladder AB, length 5 meter, weight 600 Newton, is resting against a wall. That means AB is a complete wall. Assuming frictionless contact at floor B, there is no friction here, and at wall A, here also no friction. The magnitude of force P which is required to maintain equilibrium of the ladder is. So imagine there is a one ladder and which is supported by wall AB. So here and here friction is not there. Due to weight, what will happen? This ladder will move, this B will move in this direction, this A will move in this direction, this AB will become horizontal. In order to stop this movement, we are applying force P so that this body will maintain the particular position which is given. So he is asking what is that P value. So let's take the pre-bar diagram of ladder AB. So this is AB and there is a weight W which is 600 Newton, and there is a reaction force at A, RA, and there is a reaction force at B, and there is one external force P. Here I want to give you one concept, that is, suppose take a bar AB and there is a two external forces P and F1 and there is a one support here. So if you remove the support, there will be one reaction here. It can be R1 or R2. Some people write it as a R1 which is perpendicular to the body. Some people will write as a reaction R2 which is perpendicular to the surface. So always remember that the reaction at surface on the body is always perpendicular to the support. So this is wrong, this is correct. That's why here also you have mentioned the reaction RB which is perpendicular to the support, not to the body. So that point is clear. And then here how many unknowns are there? 1, 2, 3 unknowns are there, and this is a 2D problem because it is on a plane. How many equations we have? Sum of F. Let's consider this as a X and this as a Y. Sum of X, F force along X axis is equal to 0. Sum of force along Y axis is equal to 0. Sum of moment about Z axis is 0. Here the Z axis is nothing but the axis which is perpendicular to the paper, that is this pen axis. So here let's take sum of Fx is equal to 0. Ra is equal to P. If you know Ra, we can able to find out P value. So how can we find out RA? Think. So take a point B and consider sum of moment about point B is equal to 0, because about z direction, anyway this is direction is z only, but point is B. That means if the body is under equilibrium, you can take momentum about any point, then it should be 0. You can take momentum about point B, it should be 0. You can take momentum about point A, it should be 0. Or you can take momentum about centroid, it should be 0, because the body is in equilibrium. Let's take momentum with respect to point B is 0. Why I took point B is 0? At point B we have two unknowns, RB and P. If I take about this point, the momentum due to this 2 point is 0. So the reactions will be, the momentum about point B will be only due to RA and W. That is the reason why I took moment about point B is 0. So what is moment about point B? RA into the perpendicular distance. That means, as I said earlier, force can be, I can transfer this force here, here, here. So I transfer this force here. The moment is nothing but force into perpendicular distance from the point. This is the perpendicular. What is this perpendicular distance? We already know this perpendicular distance is nothing but 3. RA into 3. So which is clockwise about this point, it is creating clockwise moment. So I consider it as a positive moment, and W is there which is creating momentum anti-clockwise. So I consider it as a, so the moment will be negative. W into, what is this distance? So if you see here angle is theta. If you consider this whole triangle, angle is theta. If you consider this small triangle also, the angle is theta. So here the whole distance is 4. Here this triangle, the distance is 2.5. That means half of the 5. So this distance should be 2. So W into 2 is equal to 0. So RA into 3 is equal to 2 into W. RA is equal to 2 into, what is W? 600. When this comes this side, it will become 3. So 3 ones are 3, 200. So RA is equal to 400 Newton. So when RA is 400, then P is equal to 400 Newton. So to explain, it may take some 3-4 minutes, but if you solve it, it won't take even a minute. Okay, let's go to the question number 6. So what is asking? Two identical truss supports. Two identical truss support a load of 100 Newton as shown in the figure. That means there are two trusses AB and BC, and these two trusses supporting the load 100 Newton. The length of each truss is 1 meter. That means BC, this length is 1 meter, this length is 1 meter, and cross sectional area is, that means cross sectional area of this AB and BC member is 200 mm square. So Young's modulus is 200 gigapascal. The force in the truss AB is, he is asking the force in the truss AB. So to calculate the forces, we don't need Young's modulus. This is an additional data, and 200 meter square mm square is also additional data. So let's take the point B. So here there is a one external load, that is 100 Newton, and let's cut here. Then there is a reaction FBC. We are assuming it as a tension to solve the problem based on the signature. Like, well, if you get the positive value, that means the direction is correct. If we get the FBC value as negative, so the direction is opposite to what we have taken. So here it is 30 degree. So here it is 30 degree. So the body or the point is under equilibrium due to three forces. They must be concurrent in nature. So this is concurrent system. So to solve this system, we have one principle, that is Lami's principle. What it says? Force 100 divided by the angle between two other forces, sine of angle between two other forces, that is total is 180. 180 minus 60, 30 plus 30. 180 minus 60 is equal to FAB divided by sine of angle between two other forces, 90 plus 30 is equal to FBC divided by the angle between two other forces is sine 90 plus 30. So he is asking only FAB, so we will focus only these two forces. 100 by sine 180 minus 60 is nothing but sine 60 FAB. Sine 90 plus 30 is nothing but cos 30. So we know that sine 60 is equal to cos 30. Sine 60 is equal to cos 30. So force in FAB, so these two get cancelled. So FB is equal to 100 newtons. So let's move on to the next question. A pin jointed uniform rod of weight W. So there is a rod which weight is W. So if the and the length L is supported horizontally by an external force F as shown in the figure. The force F is suddenly removed. At the instant of force removal, the magnitude of vertical reaction developed at the support is. That means there is a uniform rod I consider as a AB, and the weight is acting at the centroid. That means if you consider the total length as a L, then the distance between here to here it is L by 2. So initially, so here this is a hinge support. The reactions will be Fy and Fx. So initially there is an external force F here. What he did is suddenly removed it. So if he suddenly removed it, what will happen? Due to weight W, it is try to rotate about this hinge point. Correct? It's try to rotate about this hinge point. So if it's try to rotate about this hinge point, then what will happen? There is a momentum. That means M. If the momentum is there, it will create angular acceleration. If the angular acceleration is there, it will create tangential acceleration. And tangential acceleration. If tangential acceleration is there, there will be a inertial force M into a tangential acceleration, inertial force, and this inertial force is acting at the centroid opposite to the direction of tangential acceleration. So I am repeating this again. So due to W, there is a moment M about point A. M will create angular acceleration. Due to angular acceleration, there will be a, let's focus only at this point. So this member is try to rotate, this centroid will try to rotate like this. So here there will be two accelerations. One is tangential acceleration, one is normal acceleration. Here we have two forces, Fy and Fx, and here, so we all know that the inertial force always acts opposite to the direction of acceleration, that is mat, and which is passes through the centroid. That's why I represented this here. Here there is a body of weight A and the acceleration is here. The inertial force will be ma, which acts opposite to the acceleration, direction of acceleration, and passes through the centroid. So here mat, which is opposite to at and passes through centroid. And there is a one force W which is acting. So here, so summation of momentum at point A is nothing but inertia about at point A into angular acceleration. What is the moment about point A? So there is only one external force, that is W into, what is the distance between W and A? L by 2. Then moment of inertia about A into angular acceleration. So consider rod AB having length L. This is the centroid C. This is the point A. So we all know that the moment of inertia of this rod about centroid is ml square by 12. The rod is having mass m. The moment of inertia about point A is nothing but ml square by 3. So here moment of inertia is equal to W into L by 2. Moment of inertia is nothing but ml square by 3 into alpha. Then what is alpha? W is nothing but mg into L by 2. This 3 will come this side. L square will come down. M will also come down. This get cancel. L and 1L get cancel. It will be 3g by 2L. It will be 3g by 2L. Then we all know that tangential acceleration is nothing but r alpha. What is the r here? R is nothing but the distance between centroid to the point A, that is nothing but L